Hello, so this is the last math video that I'm going to be making. So I'm going to be going over a review of probability. So let's go ahead and read this first question and see how it goes. So the probability of Dan missing his flight, so Dan missing flight, is equal to 0.4. And the probability of missing his flight and staying overnight in the airport equals 0.3. So the probability of that and the probability of, now let's use some proper statistics terms, shall we? This is and, this little union here, this means and we know that we need to find the probability of him staying overnight in the airport given he missed his flight. So probability of him staying overnight given, that's what this little line means, given, if that is true already, then what is the probability of this one happening? So given that he missed his flight, well, we know that there's a formula for this, and actually there's a very handy-dandy formula in your programs. Academic 22, if you go down all the way to probability, you just type in 1, 1, 1, and go down to info. You can see each of these things. So this P of A or B, that's also looks like A upside down U, B, okay? And so this upside down U means or. And then we did see the little line there that we're looking for, given. And so we see that the probability of O given DMF, we see is equal to the probability of DMF and O divided by the probability of DMF. It's always divided by the second number, the one that's given. And so we can just plug our numbers into the formula here and see that we have 0.3 for the and divided by 0.4 for the probability of him missing his flight, and we get 0.75. And so our answer is 0.75. So this formula is quite important, and we've got the formulas here. I'm going to real quick explain a couple things about them because they don't come up in the problems. If P of A and B is equal to 0, and probability of A or B is equal to probability of A plus probability of B, then those are mutually exclusive events, so they cannot happen together. And then if A given B is equal to the probability of A alone, then those are independent events, so they do not affect one another. Versus in this case, they do affect one another because they are dependent events. So I thought that might be important to mention. And then we have this next question. A vending machine has a 0.3, so let's see, probability of breaking down is equal to 0.3, and the probability of being empty is 0.2. If they're independent, then what is the probability you can use this vending machine? Okay, so if these are independent, then we need to see what is the probability you can use the vending machine. So this is 0.7 because it's a chance of it not breaking down, because the probability of something not happening is just 1 minus the chance of it happening, so 0.7, and then the probability of it not being empty, because we want to be able to use the vending machine, times 0.8, and this equals 0.56 here, which is D. So it's just multiplying the two probabilities. If they are independent, you can multiply the probabilities together, and you'll have no rough time there. Molly's father pays for her mowing the grass $2 65% of the time, $5 10% of the time, $8 20% of the time, and $10 5% of the time. what's the expected wage? Now, this is somewhat intuitive, and I'm going to explain to you, and then I'm going to show you how to do it in the calculator. So $2 times 0.65 is the expected value of the $2. And then 5 times 0.1, as you can see, 65% is just 0.65. And you multiply these two in order to get their expected value, right? And so plus 8 times 0.2 plus 10 times 0.05. And this equals 3.9. So we can see that the expected wage is going to be $3.9, which makes sense because if you were to weigh out each of these, you have a 10% chance of getting $5, 20% chance of $8. Well, yeah, that about balances out to be about $3.9 if you think about it intuitively. Like, yeah, if I have more than half a chance of getting 2, that's probably going to be a bit lower. But then I do also have that chance of getting $8, so it could be like higher expected value and so forth. So next up is all the answers from DemiDeck are all incorrect, but I'm going to show you first how to enter into the calculator. So if you go ahead and look, we've got stat. We're going to edit the list, and we're actually going to use 2 different lists here. So we're going to use list 1 is of all the dollar amounts or all the amounts. So you may get a problem that's not dollar amounts, but just amounts in general. You're going to enter all those amounts here in list 1. So 2, 5, 8, and 10, right? And then list 2 is going to be all the probabilities. So 0.65, 0.1, 0.2, 0.05. So then we go to stat, calc, one of our stats, and then usually it's just going to look like this, list, L1, and then frequency list. You need to now use this frequency list that we've been ignoring previously. So you're going to click second and then L2, since that's your second list, and then you're going to click calculate. So as you can see, we got our 3.9 there without even having to try. And see, we got the standard deviation, which is 2.73. So remember, standard deviation squared is variance. So 2.773 squared is going to be just about 7.69. Oh dear. 7.69. Just about. And so we can clearly see here that we do not have any correct options in the answers, but this is our answer for the variance. Now, I do want to point something out, and that is there was a question at County where it asked what if the binomial distribution has a standard deviation of yada yada yada, and then it has this many trials and this many trials, what is the variance, right? Don't get tricked by those, because if it gives you the standard deviation, you can super quick give the variance, because variance is always equal to the standard deviation squared, no matter what, right? Okay. So 7.69 was our answer, and I explained how to do the expected value there. And there's also a formula in your calculator in order to figure this out if you're ever wondering. If you need the algebraic definition, you can go to info here and, or sorry, this is a probability one. There's a very similar one under measures of variation. If you go 1, info, you can see all of these, right? These are going to be very similar. Oh, these are just for regular numbers. I will enter into the calculator a couple other formulas that I will just go ahead and say now. The formula is going to be x minus x bar squared times the probability all summed up. probability of x, all summed up is the variance here. So that is your formula, or yes, that's your formula. And you already know the mean is adding all of those up, but this is the variance formula. And remember, you can always get standard deviation just by square rooting both sides. So you get that right there. And if you go ahead, yes, okay, so that is the correct formula. So yeah, if you just square root all of that, that's how you get standard deviation. Okay, next up. And if you need me to explain this, this is just, once again, a sum. We've been over this sorts of stuff. So you would take 2 minus the expected, which is 3.9, squared, multiplied by 0.65, and then you would add that to the next term of 5 minus 3.9 squared times 0.1, and so on and so forth until you get your variance. So next up, we've got binomial distribution. So this is a fun one. If you have a binomial distribution with a probability of 0.22, what's the probability that exactly 3 out of 15 trials will be successful? So how you do a binomial distribution is you go to your calculator, you go to second and then vars, which is distribution. You scroll all the way down here to binom PDF, probability, not CDF like the normal we did, or we will do. And there are 15 trials with a probability of 0.22 and 3 out of those 15 trials. So the probability here is 0.243. Now, I do want to, as we look at this, give an example of what is a binomial distribution. So let's say that you have 15 questions on a test, okay? And you want to know the odds of getting exactly 3 correct if you have a 0.22 probability of getting any given one question correct. So you either get it correct or you don't. This is where a binomial comes in because it's 2 different choices that you have. You have the choice of either getting it correct or not getting it correct. So you have this probability of 0.22, and it's when you have these correct or incorrect that you have a binomial distribution. So if you were asked a question like, there are 15 questions on a test, you want to know the probability of getting exactly 3 correct, and each question has a probability of 0.22 of happening. What is the probability that you'll get 3 exactly? Now, if you wanted, and that would be the exact same answer as this. So now, what if you wanted to get 3 or less correct? So this is an interesting question. You would have to go to binom CDF. You'll see it in the menu screen. And you do 15 trials with a probability of 0.22. 3 or less. As you can see, it's a higher probability because getting 3 or 2 or 1 or 0 correct will be different. So let's say you want to see what's the probability of getting 10 correct or less. And as you can see, it's a very high probability. And it's a low probability that you would get, let's say, 5. Not very low, but relatively low. Or less. And then let's consider if you were asked getting 3 or more correct. So it would be then 1 minus this probability, or it would be 1 minus 2 because you have to include 3. 3 or more, so you have a 67% chance of getting 3 or more correct on a test like that. So that's how each of those, so it's the inverse. That's how each of those binomial problems work. If you ever need help with extra binomial, there are lots of focused quizzes on them that you can go through and ask questions about. Okay, next up is a normal distribution, which has a mean of 44 and a standard deviation of 5. So within what interval do 68% of the data fall? Well, this is important to know about the normal distribution. You have a normal distribution here. And with a normal distribution, you have certain amount of percentages that lie within certain standard deviations of the mean. So we know that this is the mean, right? Let's call it mu for mean. And then we have 1 standard deviation, 2 standard deviations, 3 standard deviations, which is basically just a measure of how far away are you from the mean. So negative, negative, negative. 2 standard deviations, 3 standard deviations. So we can clearly see there are a few percentages that make up the normal distribution. From -1 to 1 standard deviation is going to be 68% of the data. Then from 2 to 2 is, so -1 to 1 is equal to 68%. -2 to 2 is equal to 95%. -3 to 3 is equal to 99.7%. So we can see that each of these probabilities are changing. So if we have 68% of the data, we know it's going to be -1 and +1 standard deviation. So 44 plus 5 we know is equal to 49. And we know 44 minus 1 standard deviation, which we know each standard deviation is 5, is 39. So it's going to lie between 39 and 49. Now, you may ask me, how do I figure out this another way, Bobby? Well, if you go to your calculator here, you can also go to second distribution again, and we do normal or inverse normal. Since we're given you're given a percentage, you do inverse normal. And so the area we know is 0.68. The mean is, or mu, is 44. Standard deviation, 5. Center is what we're looking for. Now, if it's, if it's asking where data falls, it's going to be center. But the problem may ask, like, this or less, then that would be left. This or right is going, or this or higher is going to be right. So you'll see that on the little thing, and just remember that. So 39 and 49 is what the estimate of this is here with inverse normal. And then let's say you wanted to check each of these individual answers. In order to do it another way, you would do normal CDF, where you're shading in certain parts to see what's the probability of getting that. So if you have a lower of 39 and a upper of 49 and a mu of 44 and a standard deviation of 5, as you can see, this is 68%, just about. And so you can trust that this is true because it lies between this number and this number, aka it lies within all of this shaded region here. So that's a brief overview of normal CDF, normal, and inverse normal. You probably won't ever use normal PDF. Okay, next up, Julie has a 0.23 probability of knowing a country's capital. And if she does know the country's capital, then she has a 0.7 chance of having been there. So she's visited given that she knows it. Given that she knows it, she has a 0.7 chance of the fact that she's visited it. So how do we find the probability that she knows the country's capital and has visited? Well, we can go back to our programs here and see that our formula is going to be, once again, under probability distribution. If you just go 1, 1, 1, don't worry about that. Go to info. You can see that the P given of A given B equals the P of A and B. Oh, that's what we're looking for. We're looking for A and B divided by probability of B. So we were given the probability of B, K, which is K in our instance, 0.23, and then V given K is 0.7. So clearly we have P of V given K equals P of V and k divided by p of k. So to solve for p of v and k, you just have to do a little algebra, multiply on both sides, p of v given k times p of k. So we're just going to multiply these two values here. And if we do that, 0.7 times 0.23, we get 0.161. Okay, and then next up, we have the variance of the probability distribution. So we already know the formula for variance, if you recall, is the sum of all the x's minus x bar squared times the probability of that given event x. Now, we have an easier way to find this, however, when we can just, once again, plug in to our stat lists. So we can just go ahead and say, oh, our value is -6 for list 1. And remember, I told you it's not always going to be dollars, it's just going to be a value. So -3, 2, 4, and then we have 0.2, 0.4, 0.1, 0.3. And these will all add up to 1 when you add them up, or 100%. So make sure they add up. So if you're ever missing one, you know that all of the probabilities add up to 100%, so you can subtract the rest out of 1 in order to get your missing probability. So then you go to one of our stats. Frequency list is still 2 there. We can see then that the standard deviation here is 3.872983346. So let me write that down so we don't lose it. 0.87298. Perfect. And you don't have to be like that many decimal places on the actual test because you want to save time, but I'm going to go ahead and do it anyways. This is about equal to 15. So our answer is 15. Okay, next up is a binomial distribution in which we're trying to find the p probability. So, like with each trial, what is the probability is what this is asking, where we have 5 trials, 4 successful trials, and the total probability is 0.0146. So what we can do, like we usually have, is check each individual answer until we get them correct. So I'm going to walk you through each of these probabilities. So let's start from the bottom, shall we? We're going to go distribution. We're going to go down. We're going to go binomial PDF, since it's exactly 4. If it was less than or greater than or whatever, we're going to do the CDF, remember. Trials, we have 5. Probabilities, 0. We're testing the probabilities, so it's 0.32. And then x value of 4, if it equals 0.0146, and that's our correct answer, which it doesn't. So we need to try again and go ahead and let's just copy that over and do 0.25. Oh, and would you look at that? That equals 0.0146. Don't forget that it may give you in percentages. So our answer is D. And then finally, we get, in a normal distribution, 2.14% of the data has a z-score in the range of blah, blah, blah. So this is in the case where we are in what's known as z-score mode in our calculators. So z-score mode is when you have a 0 and a standard deviation of 1. So the mu is 0 and standard deviation is 1. And you want to find the percent, or maybe even find one of these given the percent. And so what we can do is in our calculators, let's go back to distributions and normal CDF. And we know our lower, let's test out each of these and start at C, shall we? So we're going to start at 1 to 2, that's what those little brackets means, is it goes from 1 to 2. And then the mean is going to be 0, and the standard deviation is 1. That's what a z-score is. That's how we find z-scores based on a normal distribution, because a z-score is literally just one standard deviation. And so we check that, and it's not 2.14%. And then we check the next one, which will be 2 to 4, which is not 2.14%. 2 to 3 is 2.14%. So we can see that our correct option here that I've had circled the whole time is indeed E, because we used our normal distribution. So thank you for watching. That was all the videos I have for today, and I hope you enjoyed. Thank you.